Temperature has a tremendous effect on air. When it's cold, the air molecules are closer together than when it's warm. Also, the higher we get in altitude, the less dense the air molecules are. So both temperature and altitude affect the air density, and therefore affect the performance of our aircraft. That's because the closer the air molecules are to each other, the more of them are displaced with propellers, and the more efficient the flight is. The opposite also happens. The less air molecules are displaced by the propellers, the less efficient our flight. Humidity also affects the efficiency of our flight. Humidity is, quite simply, water molecules in the air. When it's humid out, there's more water molecules in the air, which means there are fewer air molecules, so the flight is less efficient. So the key things to keep in mind for flight performance are temperature, altitude, and humidity. So to reiterate, at higher altitudes, air is less dense than at lower altitudes. This affects the performance of aircraft. Hot air is less dense than cool air, and this also affects the performance of aircraft. Humidity is also a factor. Now let's discuss atmospheric stability. Atmospheric stability describes a state in which air resists vertical displacement. It's hard to move the air. It's just there, stagnant and still. Unstable air, on the other hand, is when it's very easy to displace the air in the atmosphere, so we get turbulent airflow. Stable air is characterized by smooth air, fair to poor visibility, stratus clouds and fog, and continuous precipitation. Unstable air, on the other hand, is characterized by rough air or turbulence, good visibility except in blowing obstructions, cumulus clouds, and showery precipitation. Weather conditions that affect performance include atmospheric pressure and stability, uneven surface heating, which causes air to rise and fall, causing turbulence, and finally, visibility and cloud clearance. Now let's discuss density altitude. What is density altitude? Density altitude is the altitude relative to standard atmospheric conditions at which the air density would be equal to the indicated air density at the place of observation. In other words, the density altitude is the air density given as a height above mean sea level. As we've already discussed, the less air molecules there are, the harder the drone needs to work to fly. And when we're talking about density altitude, the key word is altitude. So the higher the altitude, the less dense the air is. At a higher density altitude, the drone would have to work harder than at a lower density altitude, just to maintain flight. So remember that anything that reduces the amount of air molecules will increase the density altitude. These will include temperature, humidity, and altitude. Also keep in mind that beautiful, clear days like this one are usually accompanied by turbulent air, cumulus or puffy clouds, and if we do have precipitation, it's usually showery, so it rains and then it stops. Stable air has poor visibility, stratus clouds, and fog. If we do have precipitation, it'll be continuous, lasting a long time. Most of the time, we think it's the opposite, that a beautiful, sunny, and puffy cloud day will be awesome for flying, when in reality, it's not. Those days are usually super windy and bumpy.